Hi there, I'm playing with Junk again, and today I'd like to talk a little bit about soldering. Many people know how to solder, but also many people have problems doing it, and I want to show some mistakes and some tricks how it works better and easier. Everything you need for soldering is, of course, a soldering iron, some soldering tips, some parts to solder, a little bit of PCB or some wires, or maybe a switch or resistors or whatever. Now the most important thing is the soldering iron and the tips. Solder, of course, you need to. Solder wire is a mixture of tin and lead, or if it is a lead-free solder, it's 99% tin and 1% other metals. Stuff like that. Normally you have 60% tin and 40% lead, or maybe some other ingredients too, like silver is a very popular ingredient. So you have probably 1 or 2% of silver, makes a little bit stronger solder joint and looks nice. Choosing the right tip is very important. There are all kind of tips, like the very small ones here. That's one I use for SMD soldering. Goes down to the small pins of all kind of chips. Then this is what I would call a universal size. It's a chisel, a relatively medium-sized chisel. Then we have a wider chisel here. That is more for big chunky solder joints. Then you have short tips, long tips with needle pin. I wouldn't recommend to use a too small pin like this, except you're soldering very small parts. So maybe your ideal tip would look like that. That is something you can use almost for everything. You can use the wider side for regular soldering, or you can turn it for the smaller side to solder very fine parts. The first problem you may encounter is oxidation. You can see it clearly here. You see all kind of fingerprints, and the copper is not shiny anymore, it's brown. So that's a print that was in my drawer for, I don't know, 10 maybe more years. It has been used quite a time, so all kind of solderings here have been made and taken away. You cannot solder something like this. Well, we can try it, and you will see the problems. Well, it works better than I expected, but still it's not flowing really good. Maybe that's a little bit worse here. Well, it seems that my solder wire here has a good flux inside that removes all that oxidation. But let's try another solder wire. Well, this is an old soldering wire here, and you see it doesn't take the solder as good as the new one. This is the new one here. Well, it's not much better. You see I have certain problems here to get the solder. Well, it's not bad. Let's try the old again. Yeah, it's worse. So if you have problems with soldering, you should probably just change to another brand of wire. That can help. Yeah, you see it here. It doesn't fill up the entire track. Let's see with the newer one. Yeah, that's much better. So you can see there is a difference in what solder wire you use. There is of course a difference if your board is new or old. If you have a board like that, old, corroded, you take for example a 320 grit sandpaper and you clean that oxide layer off like that. And when it's shiny and new, by the way, you shouldn't touch it with your fingers, because there is not only grease, there are also acids in your sweat that makes the copper corrode very quickly. Now let's see, I take the old wire again. Let's see how it works on this cleaned pads. Yeah, well, a little bit better maybe. Yeah, it's not perfect. How is the new one working? Yeah, the new one works better anyway. And of course the contact area will be much bigger when it's cleaned. Yeah, I think you see a bit of difference. So as I said before, the flux that's built into the wire cleans away the oxide layer here, at least a little bit. It is limited, of course, but when you clean that with sanding paper, that will be okay. Now, flux is a key word. It makes, let's try this board, that's a new one. It makes the solder flow onto the pad in each direction. Let me see if I can demonstrate that. It's already a bit oxidated. And that's the old wire. I shouldn't use that anymore. Yeah, that's much better. So I show you that in close up. Oops, that's too close. Okay. So you heat up the pad, apply a little bit solder, and you see how it moves by itself around the entire track here. Then you can just place it, and that's something the flux makes. It makes it flow. That's why it is called so. it cleans the metals and it makes it flow properly. The only disadvantage is you have this kind of smoke. That's the flux that evaporates, and you have to clean your tip from time to time because it gets burned. The flux gets burned and makes a nasty black or brown crust around the tip. Well, let's see how that works. Tip cleaning is of course important, and you have probably something like that with a sponge that has to be moist. A dry sponge will not work and it will get destroyed very quickly because you burn the sponge. But if you keep it moist, not wet, don't make it too wet, just a little bit moisture, that cleans your tip perfectly. And that has to be done every couple of solder joints. Let me see how many we can do without cleaning. 1, 2, 3, 4, 5, 6. They are quite big, so I need a lot of solder and also a lot of flux accumulates on the tip. So I have forgotten how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We already get some black crust on the tip. 13, 14, 15, 16, 17. Well, I'd say at least after 20 it's time to clean that off. You can see it here. It's quite crusty. And the other problem is that this crust will sooner or later get on your board, like here. I'm forcing it a little bit now. And then you get ugly solder joints with a black crust around. And that's not necessary. So you see the first 1, 2, 3, 4, 5, 6, 7, 8 are, well, perfectly clean. Then here we have a little bit of crust, a little bit more, and it gets worse the longer you solder. So cleaning every 10, 15 solder points or joints is recommended. If you want it really, really clean, so I would say every 2 or 3 points it should be cleaned. It depends on how fast you're working. Let's say, for example, if you have a little IC like that one. I hope you can see that, or you can see that. You can, of course, solder an entire row. Oops. It's not the right position. Okay. 3, 4, 5, 6, 7, 8. And now it's time to clean. And then you can do the other side. Maybe it would be easier to solder from that side because the pins are looking outwards. Okay, it's a little bit better. I have a very thin wire, soldering wire here. Maybe a little bit thicker would be easier to handle. Okay, that's, I think, good enough. Well, that one needs a little bit more attention to detail. Okay. Yeah, I think we cannot complain about that. It's pretty clean. And I wipe my tip again. Something what many people do wrong is to try to solder with the solder that is still sticking on the tip. I'll show you that. So let's say you have a drop of solder on the tip of your soldering iron and you're waiting a little bit. Maybe you place it in the stand and do something else, and then you think, oh, there is still solder in it, let's solder that. And they try to do something like that, and it doesn't really work, especially if you try to get more solder and then you wait until all the flux is evaporated. Then you try to solder that on, and there's still a little bit of well, it works better than I expected, but it's not a nice solder joint here. You can see that it works a little bit, maybe a week, maybe two, maybe longer, but it's definitely not a beautiful joint. Now what we need is fresh solder with fresh flux. That's the most important part. And you apply it and it gets beautiful by itself. Okay, I haven't filled it up completely. A little bit more. So always solder with fresh wire with a good flux inside, and you can see the difference. That's a solder joint that looks almost perfect. It has a little bit too much solder on it. It should look more like a tent, like a piece of string that is under tension. So let's see if we can make it better. So my advice for if you solder like this, not through hole, is to put tin on the wire you want to solder, and then you put tin on the solder pad or whatever it is, and then you simply melt it together. Oops, like that. It's getting hot on the other end. And if you want to make it a little bit look a little bit better, you place some new solder in. Ouch, ouch, okay. I think that's now a perfect one. Of course you can put a little bit more solder on it if you like to have it a little bit mechanically stable. Talking about mechanical stability, solder is a very soft metal. It's softer than the ingredients lead and tin. You can almost cut it in part with your fingernail. You see that? That's it. So it is not meant to support mechanical forces. For example, if you want to solder a piece of wire to a switch like that. Some people try it in a way they put it. No, that's already too good. I have seen people trying it like this, so they put solder on the wire somehow. They put solder on the switch and then they put it together somehow, and if possible they hang it from the ceiling or whatever, and a year or maybe less this will simply break away. But not okay, that's the wire that ripped off. So let me do that the proper way. Let's get rid of that end. First you twist these wires together to make a nice end here. Then you stick it through that hole, bend it over like this, and then you solder that. Now this solder connection is as strong as the wire is. It will not break because of metal fatigue here, because for example the soft metal, the soft solder will move away. There is an example why I'm telling you that. The weakness of the solder is one cause for failure of mainboards. You probably have already seen a mainboard with a heatsink tied down by this hook and loop here. That's something common on PCs or even server mainboards. The problem is that these loops here, these wire loops, are only soldered in like any other component, and the spring here is quite tough. I would say that's about, well, difficult to guess, half a kilo, 500 gram, something like that, maybe more, and that's pulling constantly on the loop here. And one day, when it is weakened enough, maybe the temperature is a little bit higher than usual, that will simply pull out and it flies away like that, and it lands somewhere in your PC. There are two problems now. You have a piece of wire lying on your mainboard somewhere, making a short circuit probably, and your heatsink is not attached anymore. Maybe you are lucky and it sticks to the chip like this one that was sticking very strong here on the chip, but
the chip also heats up. The stickiness here gets a little bit softer, and because it only falls off on one side, the other side is pulling that down. Your heatsink will probably fall off, especially when the board is mounted vertically. Your chip overheats and your board is dead. Simply because the solder joints here have failed, and they have failed because of the constant pulling force that tries to pull against that solder. The solder is soft, sooner or later it will let go. Now what can you do? The solution is quite simple. Many manufacturers have already realized the problem, and they bend the pins a little bit. You can see they are bent a little bit like that one on this side. It's probably not the best method. I would recommend to bend it away from each other, which is quite easy on this board because they are long enough. So it will look like that. And that prevents this loop to be pulled out. It will be mechanically stabilized. It cannot be pulled out without bending the wires back. So that needs a lot more force, and that's a simple cure. So if you have a board, if you buy a new board, check that. If the pins are straight, bend them a little bit, and you will probably have many more years of a good working board. Let's talk about wires. Everyone building LED lights or whatever sooner or later has to solder a piece of wire to a PCB or to another part. So what you need is a wire stripper, an automatic one like this one. This is very cheap, costs about $5 or $7. Then you have to twist the ends, because that makes it much easier to solder. If you have very thin wires, you can also hold that part where the insulation is gone, and you twist the other part around like this to get a nice twisted wire. And then you always have one hand, you always need a third hand, so I bend the wire like this. That helps me with this trick. And then you can place it wherever you want. And that's my trick to place it, because I only have two hands like everyone else. That's okay. Now if you want to connect that wire to, let's say, an IC pin, like the ones here, then you better make your soldered piece of wire as short as possible and as long as necessary, like this. And you do exactly the same. Of course you need a clean tip, it doesn't work with old solder on it. Okay. So you can solder the wires down if you need more than one, no problem. Let's take another one just to show you that I'm not telling you any rubbish. To zoom back a little bit. Okay, where is my wire? Here is my wire. You see I moved the tip of my soldering iron back and forth to cover all the wire length. Then I cut it very short, maybe 1.5 millimeter for this work here. And we are doing the next one. Boom. That's it. Easy peasy. And as you can see, I always place the wire on the same side of the pin. Here I have it above, here too. That gives me an equal space between the next wire and so on. And it's also better to move it on the side, not on, for example, you could also put it like this. But there's also already danger that, oops, it was too fast, didn't cool down, that you touch here the next row on that side. So I would recommend you to place it like this so that the insulation almost touches the soldering point. Like that. So that's pretty nice, works pretty well, and is also pretty fast. One way to attach a wire on a PCB is simply by soldering it flat onto the spot like that. That goes pretty well, but as I said before, it's not meant to withstand a constant force here. So if you have something that moves or vibrates or whatever, if you want to be sure that it doesn't come off, there's another trick. Let's cut that away to make the wire straight. You drill some holes a little bit bigger, here, and you just put your wire through that hole entirely with all the insulation. Then you put it back again to a second hole. Then you remove the insulation, twist it together. That's important, always twist these wires together, and then you stick it through and solder it on the other side, like here. And then you simply pull it back as much as you like. And you see the wire here is still flexible and it doesn't move even if I pull quite hard. I'm almost breaking the board here. So that is as strong as this wire is. Of course, when you pull too much you will rip the wire, but at least the solder joint here is not under stress. That will not break. And the only thing you need is 2 extra holes. If you design your own board, you can do that when you design it. You just make 2 holes in your CAD program, or you can do it when everything is finished. Maybe you have a little spot where you can do that, so that's pretty tough. The most common work to do is to place small parts like resistors, diodes and stuff on an experimental board like this. Then you have to bend the pins, fiddle that in. Why not make yourself a tool? Maybe a piece of hardwood with the right size, right width here. Simply makes you a little bending tool that allows you to place all your components in a professional manner, like this. Bend that a little bit over so it cannot fall out. And clean your tip. Solder it together with fresh solder. Hold your soldering iron a couple of seconds to make the solder flow around everything, and then cut the excess wires away. Now the distance here between 2 holes, or between the 2 pins of IC like that, is 1/10 of an inch. So 10 holes in a row are 1 inch. So when you make a tool, you can cut like a small stair inside here with a 1/10 of an inch space between every step. Then you have a tool for bending all sizes of all distances of resistors and all 2 wired components. For example, like this one. And if you have not enough space, you can even put it in that direction between 2 pins. The principle is always the same. Bend it a little bit. I recommend a 45-degree bend to the outward position. And then you solder it in like that. 3. I prefer a thin solder because it's a little bit easier to manipulate, to steer it in the right direction. 1, 2, 3, 4. Okay, I see the pins are still a little bit long. That's because my cutter here does not cut to the very edge, but I have another one. I like these cutters here. They are relatively cheap. This one was about, I don't know, 19 bucks. It was one of the more expensive ones. It's made in the USA. You can also have them from China, but they won't last as long. So with a good cutter like this one, with the brand, they will last, I don't know, 10 years or longer. And what's different between the 2 cutters here, you can see that this cutting edge here is a little bit back. This one is flush with the surface, so you can cut the wire down to 0. You shouldn't cut too close, just leave a little bit of the wire sticking out, but
not as much as I did here. So for example, that one is already too much cut away. That one, I would say it's good. That one is good too, yes, but that's a little bit too close, so I already removed half of the solder, and well, that weakens the spot, but we can fix that. Okay, it's already a bit better. It's still a bit short, but yeah. Another problem is how to fix multiple wires or components together that are not on a PCB, that are somewhere in free air. Now the first step would be to put solder on the wires, and I'm doing that by placing my soldering iron on the table like that, so I don't have to hold it. Then I have two hands free for everything. Also put some fresh solder on the second part, and then melt them together like so. Now with two parts it's easy. What if you want to add a third part? So you have to hold that down somehow. You have to be quick, but that works. And to add a fourth part is now quite simple. For example, that piece of wire here. You only need to be quick, so I take a little bit and I put back my temperature to about 325 degrees. If your iron is too hot, you will melt everything and everything will fall apart, so choosing a little bit a lower temperature will help you. Okay. Yeah. Now when everything lies flat, like here, you see the problem. Three are together, the fourth is flown away. Okay, that's it. You have to be quick, so you melt only the top part, and that's pretty nice. Okay, I hope you learned a little bit something about soldering and stuff, and you had fun watching the video. Thanks for watching.